Alright, so in this video, we'll go through cosets and maybe quotient groups if the video does not get too long, right? So yeah, let's begin with cosets. Cosets are sets, as the name suggests. These are just subsets of a given group, right? Let's start decoding this with an example. Let's take a group. Let's take D4, which has E, R square, R is R90, R square is R180, R cube is R270, then R4 is this, which is R360. Okay, I hope, because it's D4, that means we are dealing with a square. That means the sum of internal angles is 360 degree. That means we need to divide it by 4, 90 degrees. So each rotation is of 90 degrees. And then we have reflections, flips. S is our standard, not our standard, my standard. Like, there's a reason we call this abstract algebra. You can write it any way you want, not necessarily in this order. And I take rotations to be anti-clockwise. You can take it clockwise. You can do anything. Okay, it won't affect the structure of the group, won't affect the operation of the group. It's just that you will define the entire group in your own terms, in your own words, but it will still mean the same. Okay, it will still be these 8 elements. Okay, so S, what I take S to be is, I take S as the horizontal flip across this axis. Okay, so there are 4 kinds of flips, this and this. Okay, so this is my S, and now other elements are S, SR, SR square, and SR cube. And it is a really helpful exercise if you see what this is, what these represent. And I guess I should do one, maybe. Yeah, why not? Okay, so this is my identity, right? Now if I'm writing SR, that means we operate from the right. So I'll first rotate it 90 degree anti-clockwise. So it will give me this, right? This is R. And then I'll apply S to this. Okay. I applied R, and now I apply S to this. So S is, like I just said, horizontal flip for me. So 2, 3, and 1, 4. Now if you carefully observe, this is just, this is a flip across this axis. See? 2, 4 are in the same position. 1 and 3 have changed their places. So this is a flip across this axis, right? Okay, flip across this axis. I hope you got it. Okay, so try and formulate what these two are. You will find out that these are also flips. Okay, there is no easier way to learn. I mean, to do is the easiest way to learn. And so yeah, let's focus on the cosets now. So this is the group, and cosets. Let's Call this G and take a subgroup H. And what should I take? E, and let's take any of these. Let's take SR, or for simplicity, let's just take S. Okay, too much simplicity is not good. Let's take SR, right? You can take S and repeat the same process which we are about to do. Okay, so is this a subgroup? Yeah, it is. It contains the identity. It contains a self-invertible element. So yeah, it is a subgroup, right? Well, good enough. We need a subgroup for cosets. Now what cosets are divided into two categories basically. Left cosets and right cosets. Okay, so left cosets, take G from the group and multiply it on the left with the subgroup. You will get a few sets which will be disjoint. These are very important points. You will get some sets which will be disjoint, and we'll call them left cosets. And right cosets, same. Take the elements from the group and multiply them on the right. You will get the right cosets. And let's start doing this. Okay, so let's take R cube. Let's take G to be R cube, and let's find R cube H. So that will be R cube times E and R cube times SR. And I hope you already are familiar with this. SR and S, R inverse and S are like R and inverse S, one and the same thing. Okay, so inverse of R cube is R in this particular case. This will be identity. Sorry, this will be the same R cube, and this I can write this as SR, and then we have got another R, and R is R square, so this becomes SR square, right? You could have also done it like this, R cube, and instead of SR you could have written R cube S, and this will be R to the power 6S, which is R square S, which is again SR square, because R square is its own inverse. I hope I did not go too fast, but it's okay. You can always slow speed and watch it again. Okay, so this is our left coset. See, is it a subgroup? Well, of course not. It does not contain the identity. We don't even need to look for anything else. So left coset of this subgroup with R cube as the element is this subset of the group. Not subgroup, but a subset of the group. Okay, and let's do something interesting. Let's also find the right coset. Okay, let's find H R cube. So this should be E R cube and SR R cube, and this gives us R cube, and here SR4. R4 is identity, so it is just S. Yeah, see, this is the left coset for R cube, And this is the right coset for R cube. And we can clearly see that these are not equal, right? But okay, you do one thing as an exercise. Take the subgroup K to be E and R square. Will that do the job? I think it will. Or if not, then take K1 as ER square and R cube, right? All the rotations. First take this and find the left and right cosets and see whether they are equal or not. If they are not, I'm not sure if that seems to be a normal subgroup. Anyway, see, I don't remember stuff. I do stuff and then figure it out. So I don't remember whether this is, you check this. However, this is definitely a normal subgroup because of the index 2. We'll cover it later maybe. You can figure it out. You can read it. That is very simple. Maybe I'll make a video on it. Anyway, you find the left and right cosets for these subgroups and you will see that in this one, definitely, and this one, I'm not sure, left and right coset for any element will be equal. And that is what tells us that the given subgroup is a normal subgroup. That is the basic identity of a normal subgroup, that its left and right cosets are equal. Okay? And as far as this given subgroup is concerned, we can clearly see that left coset is different, right coset is different, right? Oh, okay. Right. Left coset is different, right coset is different. So this is not a normal subgroup. This H that we have taken, this is not a normal subgroup, right? Okay, let's do one more interesting thing. Let's find, see, we are getting SR square here. So let's evaluate SR square H, left coset of SR square. This shall be SR square into identity and then SR square into SR, right? Just multiplying SR square, these two elements on the left side, right? So this first one is SR square, and here SR square can be written as R square S, SR. This is identity, so I can just remove it, and R square R will be R cube. See, we again got R cube. We got the same subset. We got the same coset. Okay. So what will happen is this, see, the order of H is 2 and order of our group is what? 8. Okay. So this subgroup will divide this group into 4 left or right cosets, which will be different. They're not same. I mean, left and right cosets in itself will be different. And let's put this away and focus here. These left cosets, 4 left cosets, these 4 will be disjoint. There will be no common element in any of these sets. Okay, their intersection will be phi and their union will form the group G, D8, right? So these are cosets. Okay, and I think we still have a lot of time left. I mean, this seems to be a really short video, so I'll quickly take k to be e and r square, and I'll do, let's take what, sr square k. Okay, so I get s r square and s, right? I'll get, oh, why am I rushing? I'm sorry. Wait a minute. What happened? Yeah, I'm sorry. I should not be rushing. SR square E and SR square into R square, right? This is what I do when I feel like I am rushing. I slow down my system, because when we are rushing, we always make mistakes. At least the chances, at least I always make mistakes whenever I am in a hurry. So I like to stay calm. So this is our left coset for SR square. Let's find our right coset for SR square. You can speed up the video if it is too slow for you. ESR square and yeah, ESR square and R square SR square. So this is nothing but SR square, and this is nothing but S. Left coset is equal to the right coset. Okay, let's take one more example. I mean, one more element. What shall we take? Let's take a rotation r cube. Let's take r cube. R cube k. So I'll get r cube here, and here I'll get r5, r5. But we know that r4 is identity. So I can break r5 into r4 times r, and then this r is identity, and I'm left with r. So this is r. So r5 can be written as r, right? And now let's find k r cube, the right coset for r cube of this group, subgroup. Okay. I started thinking of something. R cube, and again r5 will again get r. See, the left coset is equal to the right coset. The left coset is equal to the right coset. This implies that this subgroup is not just any subgroup. It is a normal subgroup. Okay. And once a subgroup is normal, we get another type of group out of it. We can get another type of group out of it, which is, see, this group was D4, so D4 by K. Okay, and it has nothing to do with division actually. Okay, it is just this group is a subgroup consisting of, you can either, because left and right cosets are equal, so you decide whether you want to take left coset or right coset. Anything will do, left or right, they are equal. So let's take right coset. So d4 by k, which is, okay, normal subgroup is, wait a minute, see, this is a normal subgroup, and what normal subgroups do is that they give rise to another kind of a group, which is called factor group or quotient group. Also, note that it is a group. We're not calling it subgroup because it is a different type of group. Okay? Don't compare it with D4. Okay? Like, how can we even compare? D4 has cardinality 8, and this quotient group, how many left cosets? See, R cube. So this coset has R in it. So that means Rk will be the same. Rk is same as R cube K. So first element of this factor group or quotient group is the normal subgroup K itself. Okay, it is the first element of this group, and also it is the identity for this group. The group we are just about to form is called the quotient group. Okay, just okay. So now you can take left or right cosets, anything you like. I'm taking left cosets, so I'll take RK, and by taking RK, I have also taken R cube K. Then I'll take S R square K here, see, and by taking SR square K, I have automatically taken SK because SR square K will be same as SK. Okay, now what is left? R is considered, SR square is considered, R cube, R, R square was in that. There should be one more. And why there should be one more? Because see, yeah, we can come here now. See, what was the order of D4 is 8, and order of K, the subgroup, was 2. So order of our quotient group has to be 4. Okay, and see, Rk was same as R cube K, this was same as Sk. What is left? Sr is left. Okay, so Srk, not not the Srk we are thinking. Okay, Srk, these are the four elements of this group, this quotient group or factor group D4 by K, where division literally means nothing. I mean, as such, this is a confusing notation for me. Okay, may not be for everybody, but for me it is confusing. Okay, so this is the factor group D4 by K, and it is a different type of group. Okay, so it is of order 4. It can either be isomorphic to Z4, or it can be isomorphic to D2 or K4, right? D2 is isomorphic to K4. Okay, so for K4 it has to have, all elements have to have an order 2. Okay, yeah, interesting. Let's do one more thing now since we are at it. Rk and Sr square K, let's combine them. Rk and Sr square K, if we operate them, what would happen? See, this, okay, I'm writing this will happen. Okay, so this K is combined. Actually, they change positions, commutative. Okay, so R square, this should be Sr cube R square K. I mean, okay, let me explain this. If we have A K operated on B K, then this just becomes ABK. Okay, and if it is addition, like A plus H plus B plus H, actually just becomes A plus B plus H. Okay, it's all about the operation, addition, composition, multiplication, anything. Okay, that is how these elements operate. Cosets. These are, remember, these still are cosets, and this is how cosets operate. Okay, so s r cube r square, r cube r square is r5, which is r, so this is again srk. Okay, so what just happened? Yeah, what just happened is this is isomorphic to k4. Okay, k4, or we can say isomorphic to z2 cross z2. Okay, not z4. See, because these two elements operated on gave us the third element. That means, yeah, I just know that E, A, B, C with A, B, C as A, B. This is the structure of K4. Okay. What is the structure of Z4? It is E, A square, A cube. Wait a minute. A and A square. Okay. My bad. Okay. This seems interesting. Let us forget what I just said for a moment. I apologize for the mistake. See, like I told you, I don't remember any of this. I just do all of this. And I really admire people who can remember. It is a superpower that I don't have. So, anyway, this is what we evaluated. Now let's evaluate. Let's uh, let's do this. Rk, Rk, which will be R square K. Okay, R square K. Yes, and R square K is, see, what was K? Or K was E and R square. As soon as you get an element belonging to the normal subgroup, that means that is the order. R square K will be K itself. You can multiply, you can find this R square K. See, it will be R square, and R square is R4, which is identity. Okay, so RK, its order is 2. I'm writing order like this. Its order is 2. Okay, yeah. Let's find the order of SR square K. Okay, let's find SR square K. So if I square it, I will get, okay, let me make space. SR square K times SR square K, which is SR square K, and this is SR square R square K. This is identity. R square is R4, again identity. K, we again get K. So interesting. This thing also has an order 2. So yeah, I don't know why I got confused. This also has an order 2. Can this have anything else? Order 2 means it is self-invertible. It is also self-invertible. If this is not self-invertible, then where is its inverse? No, if this is not self-invertible, then we should have another element, which should have been this, its inverse. But since it is standing alone here, oh my god, what am I doing? I'm sorry. I'm sorry for this. It happened twice. So its order is also 2. Okay. And yeah, this is isomorphic to K4 indeed, or isomorphic to Z2 cross Z2. Okay, I need to make a video on this also. It is an interesting topic. Anyway, I'll end this video. I think it got too long. And anyway, okay. So if you are stuck on any point, refer to the textbook you are using. It may not seem helpful, but do it twice, thrice. You will figure it out. Or just ask me in the comments, or watch other videos of other people. There are good videos on YouTube. Okay. Yeah, that's it.